Good day, everyone. All right, so we are looking at question 7 from the SP025 2022 and 2023 paper for the Malaysian matriculation certificate. All right, so let's look at the question. This is going to be on de Broglie wavelength, right? Let's just write down there. This is on de Broglie. Okay, just to remind ourselves. Okay, so let's read the question. A photon is a type of elementary particle, that is true, and always moves at the speed of light in vacuum. So the speed of light, if you check your constant sheet, you will have 3 times 10 power of 8 meters per second. Given that the Broglie wavelength of this particle is 800 nanometers, calculate the momentum of the photon. So for the photon, right, the photon will have a momentum of h over lambda. Okay, specifically because lambda is the Broglie wavelength, h is the Planck's constant. I just want to label that there, Planck's constant. Okay, and then now all we need to do is look for the momentum. So it's fairly direct. If you look up your value for Planck's constant, it's going to be 6.63 times 10 power of negative 34. So negative 34 over the wavelength. So the wavelength is 800 times 10 power of negative 9. Okay. Now if you key that into your calculator, what you'll find is that it will have a momentum. Let me just check. Yeah, you will have a momentum of 8.29 times 10 power of negative 28. Let me write that nicely. So negative 28. Now just like mv, it's going to be kg ms negative 1. That's the unit for momentum. Okay, fair enough. Just direct substitution, and then you'll find your final answer for A. For B, okay, calculate the mass of the photon if it behaves like a particle. So if for a particle, let me just change to green. For a particle, you will have P equals to mv. And then you remind yourself that, okay, you have the Broglie's wavelength, which is equals to h over lambda, which is what you already calculated. Okay, so we know the speed of the photon is going to be 3 times 10 power of 8. So I can just substitute those values. So I'll have 8.29 times 10 power of negative 28 equal to the mass of the photon, even though in reality it should be massless, but it's asking if it behaves like a particle which has mass. And then I'll have my velocity of that photon to be 3 times 10 power of 8. So if our photon has mass like a particle, what you will find is that it's going to have a mass of 2.76 times 10 to the power of negative 36 kilograms. Now, of course, in reality, photons has been found to have no mass, but according to this question, if it does have mass, it will have this particular mass, which is 2.76 times 10 power of negative 36. Okay, that is all from me. Thank you.